Good morning, everyone. We're going to be looking at relationships between pyramids and prisms today. We'll start off with the warm-up for lesson 12. So if you could turn to page 289 in your book, your job is to draw all the surfaces for each of the three solids. So we'll give you about 5 minutes. Miss Miller, if you'd like to press pause, and then when students look like they're done, you can hit play and we'll reveal the answers. Okay, now that you've had a chance to try these, let's go ahead and just take a look at what basically the two-dimensional images for each solid looks like. We draw the surface. What we're really asking you for is to draw what is called a net. You might remember this from previous years. A net is a two-dimensional representation of a solid. So it's deconstructing the solid to put it into two dimensions. Now, I will say right away, you do not have to draw this. If you just drew each shape, each face individually, that's fine. A net is just a way of kind of linking that together. So let's look at the rectangular pyramid here. I drew my base first with the rectangle, and then I drew the triangular sides. It's kind of like the apex unfolded and turned into this solid. One of the things I would like you to do is, however you drew your shape, can you go ahead right now and label some congruent markings? Just remember the apex is kind of the top part, and notice this apex is actually kind of represented on all four tips of the triangle. But the piece I want you guys to mark down are the congruent pieces. Notice each one of these lengths from the vertex of the base to the apex, they're all congruent. So I can actually put congruent markings. I know my picture doesn't really do this justice, which is why the congruent markings are important. But all of those lengths are isosceles triangles. Right? Now, if they would have told me this was a square base, I could have drawn 4 congruent triangles. I decided to call it a rectangular base because I wasn't sure. But then I could actually add congruent markings here, because I know that those two side lengths are congruent in a rectangle, and add congruent markings here, because I know that opposite sides of a rectangle are congruent. Which actually tells the person reading this that I have 2 congruent isosceles triangles, one on top, one on bottom, and then 2 more congruent isosceles triangles on the left and the right. All right, let's look at the next solid. Now, the key with this solid is identifying what is the base. Remember, base doesn't always mean bottom, but in this case it is. The base is a triangle. And if it was a right triangle, they could have put a right angle there. I drew my net of a triangular prism like this. And let's add congruent markings. So let's pretend that this is a 90-degree angle, so it's a right triangular prism. Then I would draw one triangle on top, one on bottom. And now here's the key part, congruent markings. Right? We want to make sure our congruent markings all match up. So what has to be congruent? Well, obviously, this side length and this side length here have to be congruent. Those are the easy ones. But what about the short side of the triangle? Well, that short side has to match up with this short side, but it also matches up with these 2 side lengths. Because if I was to fold this rectangle straight up off the page and fold up with this triangle, these 2 side lengths would meet, so they would have to be the same side length as well. Likewise, the hypotenuse of the triangular base has to be the same length as the longest part of this rectangle. And same thing down here. Right? Because this length, if folded up, would match on that, and those lengths would have to be congruent. And then I'm just going to use a different color here, but notice the height of this triangular prism is the same throughout. So then I should mark the height between the 2 bases. So when you do draw nets or you draw your surfaces, you should add congruent markings so the reader knows exactly what's going on. All right, what about the cone? This is always the fun one, is what happens if I deconstruct a cone? Well, the first part is pretty friendly, right? The base of the cone is a circle. But how do I unravel a cone? Well, picture if I was to just cut along one of the sides and then fold it open. It would be what we call a sector of a circle. This isn't a perfect drawing by any means, but the idea here, and actually we'll probably explore this later on, so I don't want to give too much away, but I'm just going to add a couple of pieces. I know that the radius is this length right here, and then I know that the height, I should be careful, the height is the dotted line here. That's the height of the solid. The side length of the cone, which is kind of interesting to call it a side length, that's represented right here. And we'll explore this, I'm sure, in future lessons, so I don't want to dive too deep into it right now. All right, those are your nets. Notice each face is represented by a two-dimensional drawing. So we kind of already talked about the names of each solid. What are some things that are the same and different about the surfaces of prisms and pyramids? So think about that, so you can kind of answer that question. And then, which is the only surface that is not a polygon? That's kind of the one thing I wanted to talk about here. The only surface that is not a polygon is the one with the cone, right? And it's actually in the cone, when we unravel, anytime you have a circle or a curve, that is a non-polygon. Polygons have to be made up of straight edges, and it has to be an enclosed figure. When we have curves, those are not considered polygonal bases or polygonal sides. All right, we're going to actually skip 12.2. It's a card sort. What I'd like to do is we're going to jump right into 12.3. This is an activity where you're going to work with your group. I'm going to explain it first, and then you guys will be given some time to work through this activity, and then Miss Miller will pause the activity and we'll play it in about 15 minutes or so once I get done explaining it. So today you're going to need the stack of 3 nets. Each group will get 3 different pyramid nets. You're going to cut them out with scissors, and then we'll have to tape them together. Please conserve tape. We don't need to go crazy with it. In this activity, you will work in small groups. You'll work within your groups. Each group will get 3 pyramids. Then you will use your pyramids to make another solid. We'll talk about that in a little bit. Big thing today is make sure you save your solids for later use. We're going to use it later on tomorrow to help us come up with some ideas on volume. All right, so here's what we're going to do. First thing is, when you get your papers, before you even cut them out, put your name right next to the letters P1, P2, and P3. That'll be on the actual shape itself. And then you're going to cut out the net. Do not cut through the net. You want to only cut around the figure. And then you're going to actually take and fold all the sides up so that net will turn into a 3-dimensional solid. Make sure the printed side of the net is facing outward, so when you fold it up, you should be able to see your name on the outside. All right? Your job then is to assemble the 3 pyramids. So once you have all 3 pyramids created and taped together, then you're going to put all 3 of them together to form a triangular prism. Each pair of triangles with a matching pattern will come together to form one of the rectangular faces of the prism. You will need to disassemble the prism later on, so if you are going to tape it together, please use very little tape on putting the 3 pyramids together. If possible, try to do it without using tape at all, so it's easy to disassemble. These directions are also found on 12.3 activity in your book, so you can read through them. Once you have your final, that big solid put together, we want you to make a conjecture. So this would be question number 3. Make a conjecture about the relationship between the volume of the pyramid, marked P1, and the volume of the prism. So you're comparing the shape P1 to the big shape of all three put together? And then what information would you need to verify that your conjecture is true? So, Miss Miller, if you'd hand out the 3 nets to each group, they can start cutting, assemble. You can press pause, and once the groups have had a chance to assemble all 3 pyramids and then put them together to make a prism, then go ahead and press play again. My guess is it'll take about 10 to 15 minutes. Wonderful. That was exciting, right? You guys had a lot of time. Hopefully you didn't have any paper cuts. Let's just show you what you should have ended up with. So here's an example of the 3 pyramids that you would have put together. And then when you match up the side lines that are the same color, or dotted paper, shaded paper, or open, you should put those together. Your solid should look like this right here. All right, kind of a larger view. I'll see if I can shrink it down a little bit. So this is what your solid should look like when all 3 come together. All right, let's kind of talk about question 3 and 4. Hopefully you had a chance to go through and work through those as well in your group. If you didn't, then let's press pause on the video and make sure you had a chance to talk about questions 3 and 4. And we can press play in a couple of minutes. Okay, so once you had a chance to go through and talk about question 3, your goal was to make a conjecture about the relationship between the volume of the pyramid marked P1 and the volume of the entire prism. That's all 3 solids put together. So how does the volume of the pyramid P1 relate to the volume of the prism as a whole? Remember, a conjecture is an educated guess. We're actually not going to tell you the answer yet. This will be a little bit more open-ended today. But in order to make sure your conjecture is true, what information would you need to verify that your conjecture is true? So hopefully you said some things like, well, the dimensions, maybe the area of the base, the height of the solid, or just knowing the side lengths of the actual shape itself, the pyramid or the prism. Then you could calculate the volumes to help you make your conjecture. We'll be doing that officially tomorrow, so hold tight on that. You'll get those questions officially confirmed tomorrow. All right, so let's just take a look here at the pyramid marked P3. Which face would you consider to be its base? Is there only one possibility? So take a look at P3 right now and discuss with your group. Which shape would you consider the base? And is there only one possibility? Okay, and then which faces of the prism are its bases? So think about the shape as a whole. Can you identify the bases of the big solid, the prism, when all 3 shapes are put together? Do the pyramids marked P1 and P3 have any congruent faces? If so, how do you know? We're going to answer the first 2 officially tomorrow, but I can answer this one pretty quickly. When you form the 3 solids to create the prism, any solids, any faces that are officially touching should be congruent. All right. Do the pyramids marked P2 and P3 have any congruent faces? If so, which are they and how do you know? So why don't you take a minute here to just go through and confirm with your group these 4 questions and have a conversation about each one of those. Miss Miller, you can press pause for maybe a minute or 2 to let the kids think about these problems. Okay, now that you had a chance to talk about those, let's just kind of synthesize today's lesson and what should you take away from it. So let's consider what information would be needed to show the volumes of the pyramids are equal. So here I have 2 volumes. You can see 2 solids. They're both pyramids. And they have the exact same base, a 5 by 5 square. So how do you know the volume of the 2 pyramids are the same? Why do we know that? Well, let's take a look. Remember when we estimate volume. Volume is always the area of the base times the height. And in this case, the area of the base is 5 by 5, or 25 units squared. And then the height is indicated by the perpendicular distance. In this case, it's from the center of the base up to the apex. And that has a height of 7, so 25 times 7. I believe that's 175. Now let's check this is kind of what we would call well, this shape here is a right square pyramid. This would be an oblique square pyramid because the apex is not directly above the base with a perpendicular. But notice the base is the same, right? Same base, same height. The area of the base is 25. The height is also 7. So without even doing any calculations, you could have said that the volumes are the same. And then your justification would be they have the same area of the base, and the solids have the same height. So that's by Cavalieri's principle that we talked about the other day. It says, what would you need to know in order to verify what we think about the volumes of these two pyramids? We kind of already talked about that. You need the area of the base and height to officially calculate the fact that their volume would be 175 units cubed. All right, so today I'd like you to annotate the Lesson 12 summary on page 293, complete the practice problems 1 through 8, check solutions online when they're available, and don't forget to keep working on your Delta Math and your corrections for the last quiz. Hope you had a great day. I'll see you soon. Adios.